All right, let's start. So this class we'll start discussing kinematics. You know what kinematics is? You understand what kinematics is? Study of motion. Kinetics is also study of motion, right? What is the difference between kinetics and kinematics? Not that's statics and dynamics. Huh? Both are motion of particle. Kinematics and kinetics are both motion of particle, right? Force. So when you are studying kinematics, you're mostly tracking motion. You're not concerned about the applied force. Okay. So if you have, let's say you're given a reference frame, and this is where your all the vector mathematics you studied, vector mathematics you have revised, will really become important. Okay. So you have a reference frame, x, y, and z, and you have a particle here. Okay. So if you have a particle P, and let's say you define the position of the particle as r is equal to x of t I plus y of t j plus z of t k. So what is x, y, z? X, y, z are the components of this particle in the x, y, and z direction, and I, j, k are the unit vectors in this direction. Okay, it just means, so you can take these as I, j, k. Are components. Components are, we did that, right? We project this onto the each of these unit vectors. These are the components you're going to get. Okay. What is a coordinate system? When you think about a coordinate system, what do you think about? What does it facilitate? Huh? Not quadrants. It facilitates a measurement system. Okay. So when you say unit, there's a reason you say this is unit vector, because see, this is x into those many units. Okay. You see that? So this is the length, right? The magnitude. X is the component. When you do the projection, this vector, this is not in JK plane. You get that? So it is somewhere in between in this 3D space. Now when you project it onto the I-axis, whatever the length is, that is this length. Right? So what we are doing is, I means it's a unit vector. It's in that direction. So these many units. And this is again Y in J units, Z in K units. Okay? So this is how you define the position of any particle. What does R, the magnitude of R, equal to here? It is again x square plus y square plus z square, right? Notice how only this one has t. These don't have t. I'll get to that, but now you have to understand this particle is in motion. This particle is in motion, okay? And we are trying to track the position at a given instance of time. So that is that t. So this you can think about as r of t. All right, and r is this is also equal to root of r dotted with r. So this is the position, this is the particle, this is the velocity, and this is the acceleration. How do we calculate the velocity? Velocity would be derivative of r. So you have the r of t, which is dx of t over dt I plus dy of t j plus j. And this is your Vx t I plus Vy of t j plus Vz of t k. And finally, acceleration A of t is equal to d over dt v of t, which is equal to d dx of t I plus d j plus d c of t. Okay. And this is equal to ax of t I plus ay of t j. this is here, understand what we are doing. We are doing kinematics, right? We are tracking the motion. We know the position, right? And if we take the derivative of that, we are going to get the velocity and acceleration. And the reason this is kinematics is because there is no force involved. We are not applying any Newton's laws to figure out the motion. Okay? We are only tracking motion. And when we talk about time derivatives, we will use V is equal to R dot A is equal to V dot, which is equal to R double dot. Vx is equal to x dot. Vy is equal to y dot. Vc is equal to z dot. Similarly, Ax is equal to Vx dot, which is x double dot is equal to y dot, which is equal to dot, and Vc is equal to dot. Any confusion? Hope it's clear, right? Yes. Yes, Anu. Right. You're right. Good catch. Right. All right. So it is dt, yes. Now, you have to pay very careful attention to vectors and scalars. I rarely write something, write a vector and mean it a scalar. These are actually vectors. These are scalars. You have to notice that. So these are scalars. Each of these components are scalar. This is the vector. Okay. So you have to always keep an eye on that. And if you feel there is something wrong, you immediately point it out, like she did right now. Yes.
So we have or is that a vector?
This one? This one is a vector. Yes, you're right. Yeah. So if you see a mistake, if you see there is something wrong, missing, then please let me know. Okay. Because you don't want to confuse vectors and scalars. Now, here is something interesting, okay? V is not equal to R dot. Which means magnitude of derivative of R is not equal to derivative of magnitude of r. Hmm? Try to understand what we mean by that. So how do you take the magnitude of this? How do you get this quantity? Huh? So you take the derivative of this, get this, and take the magnitude of this, right? How do you get this? You take the magnitude of this and you take the derivative of this, right? So think about it. This is another r, okay? Has the velocity changed? Let's say the length of this r is the same. R and R1 is the same, okay? This length and this length is the same. This V would be whatever R1 minus R2, right? And the derivative of that. Now, if you do this one, it will be 0. This will be 0. Get it? The right hand side will be 0. The right hand side will be. So you take the magnitude of this. You take the magnitude of this, and you figure out the difference. The derivative. What is derivative? Derivative is essentially difference, right? Time difference. Time difference in two quantities. So time difference in these two quantities, the magnitude of these two quantities is 0. But the velocity is not 0. Velocity component is not 0. There is velocity. If you look at velocity, it has gone from this point to this point. Okay? We will be discussing a lot about, or all our discussions will start from Newton's law of universal gravitation. Do you guys remember Newton's law of universal gravitation? Huh? So you have f of g equal to g right? Huh? We'll get to the vector part in a second. So how do you if you're asked to explain, or if you're asked to say in words Newton's law of gravitation, could you explain Newton's law of gravitation? Okay. The force of force of attraction, yes. When you say proportional to, not radius. Right. If you have two bodies, the force of attraction between those two bodies, this is true for any bodies, okay, is proportional to the product of their masses and inversely proportional to the square of the distance separating them. Now, since we want to get rid of that proportionality sign, we introduce a constant called the gravitational constant, right? And the gravitational constant is a property of those two bodies. It's always specific to those two bodies. And when we deal with really large bodies like Earth and Moon, this changes, right? So when you're talking about, this is Newton's law of gravitation. Do you understand the difference between weight and mass? What is the difference between weight and mass? Huh? Huh? So you can actually define weight. Weight is a force. It's not a content. So mass is it's your content. It's what you are. Gravitation, weight is what you exert. Okay. So weight is equal to so this is Gm over r square is, so weight, I just put the weight as m is the mass of the larger body. Larger body here is, it's the Earth. This is a smaller body, which could be one of you. And this is the, what is this distance here? The core, the center, okay? That is this distance, okay? So assuming Earth is a perfect sphere, and what your weight anywhere on Earth would be this. And this is, what is this G? What do we call this G as? Acceleration due to gravity. Right? Gravity and acceleration due to gravity are two different things. Okay? Now even the concept of gravitation, gravity is being redefined. So what is gravitation? Huh? What are the forces? What are four types of forces? Remember? Anybody? Right. So the four types of forces which we know of, which exist, are electromagnetic force, gravitational force, and weak and strong nuclear force. Okay. So the acceleration due to gravity is, it's acceleration. Okay. So now gravity is being regarded as a wave. Right. It's this has You don't want to go out and say gravity is a movie. You can still say it is a force. As when I learned it, it was a force. All right, Matthew. Hmm? See, when you talk about forces, you have to talk about energy, right? So, what do you understand by energy? Does anybody understands energy here? Huh? What is energy? We don't understand energy. Okay. So if you want to if you want to graduate, join grad school, the one topic you might take up is what is energy? Huh? What causes energy? All right. The next this thing is Newton's second law. Okay, we're going to use this a lot. Well, we're going to start with this, and then all our basis is this thing and this thing. Okay. So what does Newton's second law state? You have F net is equal to so this is the actual definition. This is how it's defined, or this is how you it's the sum of external forces acting on any body will result in a change of momentum, linear momentum. And so Newton's second law is all Newton's laws apply for translational motion, and Euler's laws apply for rotational motion. Okay. And when you study dynamics, you study Newton-Euler dynamics. Newton-Euler. So this is, you pronounce it as Newton-Euler, okay, or Euler. So Newton-Euler dynamics is translational and rotational motion. So when you talk about rotational motion, what is this F? What is F? What is F called when you talk about rotational motion? It's torque. And what is this? This is angular momentum. So applied torque is equal to change in angular momentum. That's what you want to get. Okay. So these, let me just give you some ideas here. You have So the impulse force is defined as the sum of forces between applied forces between time t1 and t2. Okay. So let me try to introduce angular momentum. Okay. What is moment of a force? You understand moment of a force? Right. Moment of a force so this is I, impulse. So moment of a force, the way you read this is the net moment about point O is equal to the distance r crossed with the force. Okay, this is not multiply sign. When we are dealing with vectors, we cannot use multiplication or division. We have to use dot products and cross products. Okay. R cross, its moment is R cross F, right? So if you're applying, it's R cross F. It is not F cross R. So you have this, you have R crossed with M A, okay, which is R. And actually we'll end up doing this again. So look at this. Here R cross M dV over dt is equal to d over dt into R cross M dV over dt. Okay? Make sense? No? Make sense now? So if you split this open, d over dt of R cross mv is what? You have R crossed with M dV over dt plus mv into crossed with dr over dt, which is, this is v, right? And what is the vector crossed with itself? It's 0. Vector crossed with itself is 0 because vector crossed with itself, how is cross product defined? Magnitude into sine. So the vector, the angle between those two, the same vector is 0, right? So it will go to 0. So this is what you end up. So you can write it as this one. But what is this quantity here? R cross mv. This is actually angular momentum. This is how you define angular momentum. mv is momentum, linear momentum. R cross mv is angular momentum, right? So you can say net moment is equal to change in So now you compare this one and this one. So here it is force. This net moment is nothing but, what is moment? It's torque. You see torque, right? So applied torque is equal to change in angular momentum. Applied force is equal to change in linear momentum. You see the relationship? This is what Euler came up with. Huh? That is H, yes, H. So you always consider momentum about a particular point, right? Applied torque is equal to change in angular momentum. Applied force is equal to change in linear momentum. So force is a linear quantity, correct? Torque is angular quantity. Right? Now, you can also define whatever if you can define in a translational system. This is linear impulse, right? Change in the net impact of the force between time t1 and t2. How is force defined? Newtons, right? So it is Newtons is what? Kg meter per second, correct? So per second. So it is a per second quantity, it is a rate. Impulse is a net impact. It's a total energy. Okay. Similarly, you can have angular impulse, net impulse, so net angular impulse. So it would just be I is equal to integration of T1 to T2 into F dt. M dt. Got it? So next class, what we are going to do is, please go back. See, I've told you always, in that email also I've mentioned. Go back and brush this. Just read the textbook, read the notes, brush up. Okay. So next class, what we are going to do is, it's going to get even more complex, or this is all about relative motion. Okay. So next class we are going to start discussing relative motion, where when we discussed Newton's laws, right? You remember that Newton's laws apply only in a inertial frame of reference. What does that mean? Non-accelerating frame. Okay. Newton was, to think about how he imagined that or how he thought about that is very, very, very commendable. He said, even to say that, just assume that there is a inertial reference frame somewhere. We don't have inertial reference frames, but he said just assume that there is, and apply these laws. Now, when we're discussing relative motion, we cannot discuss relative motion in the context of an inertial reference frame, because no motion we study is in an inertial frame. Anything we study here is accelerating. Earth is accelerating, right? Earth is accelerating around the sun. If it was not accelerating, what would happen? It would spiral in. It would spiral in and go into. And whatever we launch out of Earth, that is also accelerating around Earth. Moon is accelerating around Earth. So what is that reference frame which is inertial? Do we know what are that reference frame we're talking about? Inertial reference frame. Where is Newton's laws? If he says these laws are applicable only in an inertial reference frame, and nowhere in the known universe you can find an inertial reference frame. Huh? Sun is also, if you look at anything that orbits Earth is accelerating. So your Earth is accelerating around Sun. Sun is a solar system. There are many solar systems in the galaxy. Galaxy has a center that is rotating. Galaxies are accelerating around, let's say, a black hole, something like that. So if you go on doing that, there is nothing which you can think that there is not accelerating. You don't know where the center of the universe is. All right, so we'll talk about relative motion. Please brush up these concepts, okay? Please give me your attendance.